Assalamu alaikum. Hello everybody, dear students, welcome once again. This is a very short video about inequalities, absolute value or modulus. The exercise has two questions. Let x, y, u, v belongs to R, real numbers, all of them. Show that the absolute value of x plus y over 1 plus the absolute value of x plus y is less than or equal to the absolute value of x over 1 plus the absolute value of x plus the absolute value of y over 1 plus the absolute value of y. The second question B, the absolute value of x minus u minus the absolute value of y minus v less than or equal to absolute value of x minus y plus the absolute value of u minus v. The first one is a little bit important in the sense that we will be solved once again when you will do metric space. This is the third condition axiom of triangle inequality, and this is define a distance if we consider the distance between x and y. This is in topology in general. Very easy way, very easy and short way. For A, to solve A, let us consider the function g of x, which is equal to x over 1 plus x, and let us study this function for x belonging to 0 plus infinity. On this domain, a chosen domain which fit very well with this function, not the domain of g of x, just we need to study the function here since the absolute value is positive or equal to 0. Now, g prime of x is equal to 1 over 1 plus x squared. On this domain, this is strictly greater than 0. This means that the function g is an increasing function. So g is increasing on 0 plus infinity, and then if we have A and B such that if we have capital X and capital Y such that capital X is less than or equal to capital Y, this implies that g of capital X is less than or equal to g of capital Y. Why? Because the function g is an increasing function. Let us apply this property for x plus y, which is, we know that this is less than or equal to the absolute value of x plus the absolute value of y. This is the triangle inequality, and from here we get, by applying this idea, we get the absolute value of x plus y over 1 plus the absolute value. So we replace capital X by the absolute value of x plus y. Here we consider capital X is equal to the absolute value of x plus y once again, which is less than or equal, using this inequality, the absolute value of x plus the absolute value of y over 1 plus the absolute value of x plus the absolute value of y. And this one is exactly the absolute value of x over 1 plus the absolute value of x plus the absolute value of y plus the absolute value of y plus over 1 plus the absolute value of x plus the absolute value of y, which is less than or equal here. If we take y equal to 0 from this inequality, we get the absolute value of x plus 1, the absolute value of x. This is the greatest value of this relation, plus from this side we get the absolute value of 1 plus the absolute value of y, the same technique, which gives us in a very short and quick and nice way the proof of this basic inequality. For the second one, actually is most faster, we can get faster the solution in the following way. So, we know, or we are supposed to know, that the absolute value of capital X minus capital Y, the inverse triangle inequality, this is less than or equal the absolute value of capital X minus absolute value of capital Y. So for X is capital X equal to X minus U, and capital Y equal to Y minus V, we get here absolute value of X minus U minus Y minus V. If we use this proved inequality, we get here absolute value of X minus U minus Y plus V, which is equal to X minus Y plus V minus U, this one, and using the triangle inequality, we get less than or equal to X minus U Y plus the absolute value of V minus U, and this is exactly the absolute value of X minus Y plus, if we take minus as a common factor, we get here using property of absolute value. We know that the absolute value of A is equal minus A, and this ends this short and sweet inequalities. Thank you for watching. Hope this can help you a little bit. See you next time.